Okay, for today's lesson, we're going to be looking at pressure and thinking about that. Well, a quick start question for you to discuss on the board. You might want to just show your teacher who's in the room with you what you think your answer is going to be. You might be able to undo it with your hands if you've not got whiteboards. Just show with like, do you think it's number 1 or number 2, and try and explain why. Okay, so if your teacher could just ask a couple of people what they think about this and why. Okay, so which of these shoes would you wear to cross this muddy field and why? Okay, so if you want to pause it, discuss it, and then I'll come back to you in a second. Okay, so hopefully most of you were sensible and said that you would wear number 2. And the reason for that is that number 1 has a smaller surface area on the bottom. This means you'd be more likely to sink. This is all to do with something called pressure. Okay, and today your title in your book should be pressure in a gas. Your keywords that I want you to write down are collisions, pressure and temperature. I want to know what causes pressure in a gas. So can we please write down your title, obviously your date today, and your keywords, please. So go and pause it. Okay, we're ready to move on. Right, so if we have a large force over a small area, we get a high pressure. But if we can spread that force out over a large area, we get a low pressure, because pressure is, okay, so pressure is the force over a certain area. Okay, so it's basically talking about not just how much force you've got, but how spread out that force is. So back to the shoe thing, okay, the high heels would sink into the mud, because even, well, think about if you were wearing both these shoes, if you went on the field in one shoe and another, you're the same person, you're the same weight. So the force you're pushing down on the floor is exactly the same. But number 1's going to sink more because the pressure's higher, because the area it's spreading your weight over is smaller. So a lower pressure is a force spread over a large area like number 2, and number 1 is going to give a higher pressure because it's spreading the same force over a really small area. Okay, so looking back to these, something like an arrow has a very sharp point, so it's a very small area, so it's got a very high pressure, whereas something like a snowboard, you're spreading your weight over a really big area, over the entire area of the board, and therefore you've got a really low pressure, so you're not going to sink into the snow. So pressure is force over a certain area, and these things are true. So the higher your pressure is, generally the smaller the area is and the bigger the force. And if you've got a small force over a large area, then you're going to have a very low pressure. Okay, so I would like you to next, if I pause it again, and you've shown this, to decide which of these is the best definition for pressure. Now, I would maybe want to pick more than one if you want to. It's okay. So if you've got whiteboards, do this on your whiteboards. If not, just discuss it. Which ones do you think you would pick as the best definition for pressure? So you can pick more than one. Okay, so pause it, pick your answers, discuss it, and then we'll start again in a second. Okay, so hopefully you would have picked, well, we'll go through each one. Okay, so we'll see if it's good or not. Okay, so I'll highlight it if I think it's a good answer, and I'll not if I think it's a bad answer. So the first one, pressure is force acting over a certain area. That's a great answer. Okay, so I would highlight that. We'll highlight it properly though. Okay, so pressure is the force acting over a certain area. Okay, so I would highlight that. That's a good answer. B, I don't think that's a good answer at all. Pressure is area acting over a certain force. They've got area and force the wrong way around in this one. Okay. Right, next ones. Pressure is higher if the force is higher and the area is smaller, or is it pressure is higher if the force is lower and the area is larger? So pressure is going to be higher if the area is smaller and the force is higher. So C is correct. Okay, so that is a much better answer than D. Now, what I want you to do is to put these two answers together in a definition for pressure in your books. So I'll write that up so when you pause it, you know what you're doing. Okay, so in your books, put these two answers together. Okay, so these two answers go together to make one definition. So start with A or C, whichever way around you want to go. Okay, and I want them to put into one full sentence for one full answer. Okay, so writing down in your books a definition for pressure using these two highlighted answers here. Okay, so pause it and off you go with that. Okay, now next thing you need to do, you should have in the room somewhere a set of sheets with some information about pressure, a few little pictures on there, and then lots of questions down the side. Now, what I don't want you to do is rush in and start answering those questions, because if you do that, you might get some of them wrong. So what I want you to do is spend a couple of minutes reading. So every time I show you something to do, if somebody could just pause the video again and just give you time to do that. So if you get a couple of minutes to just read through the passage you're given, and read the questions, okay? So don't answer the questions, just read them. Okay, so pause it now, read the passage. Okay, next thing I want you to do is either circle or highlight any words you're not fully confident on, or that you think you'll need to know the meaning of to understand the text. So we're clarifying some words, and this is your clarification sort of bit that we're going through now. And I want you to write those words in the little keywords box you've got at the bottom. So you should have a little box saying keywords, and I want you to circle or underline or highlight them, any sort of key important words that you think you're going to need, and give yourself some time to discuss that with your partner who you sat next to, please. So pause again and do that. Okay, once you've done that, I want you to read the questions again and highlight any text or underline any text which could help you answer the questions. And once you've done that, then I want you to actually answer the questions. Okay, so if you right, in fact, before you pause it again to answer the question, sorry, I want you to do that, and then I'm going to put the extra questions I want you to answer up on the board. So basically, this will be the last bit I talk to you about. Okay, because I'm going to put all this up on the board for you to do. So this should take you quite a long time. This should take you the rest of the lesson. So once you've read through everything, gone through it all, highlighted everything, picked out your keywords, discussed them, then you're ready to answer the questions. Okay, so read through, answer every question on the sheet. Okay, your answers should be also in the cover folder. So if your teacher's got the cover folder open, they should be able to show you the answers at the end. Okay, and once you've done that, use that to help you, use the text to help you, and use your answers to help you to answer this big question. So the big question is, how does an increase in temperature cause an increase in pressure in a gas? It's a 4-mark answer, so it needs to be a big paragraph written with everything. But I've broken it down into some success criteria that you need to do here, so I'll leave those up there. So it's 5 success criteria. I know it's only 4 marks, but if you write all these 5 things, you will definitely get those 4 marks. So go through, try and write this full answer. So by the end of the lesson, I want everyone to have answered all those questions on the sheet and this big question here, and some of you should have a go at this extension question again. So if you compress a gas, so basically if you squash, so if you had a balloon, you squash it into a smaller volume, how would that affect the pressure in that container, so inside the balloon? And try and explain why. And now every answer you need to be coming to needs to be in terms of, and this will be clear when you've read the sheet, collisions with the container. Okay, so this will be the end of the video now, so if you want to leave it paused on this, or if your teacher should have these slides available, so they should be able to show you it. Okay, and I'll hopefully see you soon. If you work your way through those, the answers should be on the available to you as well. Okay, so I hope you're all well. I hope you have a good rest of your day.